Hi, this is Andreas from Prediktera. In this video tutorial, I will show you how to import your images into Evince so that you then can start to analyze them. Once you have started Evince, select to create a new project. Then browse your computer to find the image files you want to analyze. A number of different file formats are supported in Evince. For example, env files and most common other file formats for images, along with MATLAB files. If you want to analyze many images at the same time, you can do that by merging them together to create a mosaic. Select the files you're interested in by holding down the Shift and Control key on your keyboard. Press Next, and then Yes to approve the merge. In this example, we have 7 images of plastic bags containing powder that then will be merged together into one big image. I now have a different example I want to show you, where I will analyze an image of a plastic bag containing tablets. In the first step of the data import wizard, we get a pseudo RGB image of our image file. And if I move the mouse around here, I can actually see the spectral profile for the different pixels in my image. If I hold down the left mouse button on my mouse and drag across the image, I can visualize 10 representative spectra from that region of interest. In the data summary, we can see that we now, in this dataset, have 299 rows and 320 columns of pixels. And we have 239 channels of spectral variables. If you're interested in only analyzing a part of your image, in this example, I only want to look at the pixels containing my tablet samples. I can just hold down my left mouse button to select my area of interest and press Include Only to crop the image. It's also possible to change the selection to be vertical, or if I want to, horizontal. There is a zoom function if I want to magnify part of my image to look closer. If I want to crop certain parts of my spectral variables, I can also do that. If I have a large image file, I might want to remove... If I am trying to import a large image file, I might want to reduce the size of that file to speed up the data processing. In the Data tab, I can see the estimated memory usage of my Evince project. In this case, 73 megabytes out of the 23 gigabytes of RAM I have available on my computer. By reducing the resolution of my image, for example, using every third pixel in my rows and columns and every third spectral variable, I can reduce the memory usage. In this case, it's only 2 megabytes. And as we can see, we have a much more pixely image here. So we do lose some of the interesting information. In this case, I have plenty of raw memory, and my image file is not that big, so this is not really necessary. In the next step of the data import wizard, I can choose to use a separate dark and white reference to normalize my image. In some cases, Evince will automatically detect your dark and white reference, but you can also browse your computer to manually select your reference files. If you don't have a separate reference files, perhaps this normalization has already been applied to your image before you're trying to import into Evince, you can simply skip this whole step. There is an option to convert your image to reflectance, or as we recommend by default, to have it as pseudo-absorbance. There's other settings to cap your reflectance values that are higher than unit 1 in your spectra, or to replace spikes in the spectra with median. These kind of spikes can sometimes be seen if you have problems with the detector in your camera. In the third step of the data import wizard, we provide a name for our Evince project. And we then also select a template that will be automatically applied to the image as it's being imported into Evince. With the standard image template, it will just apply centering to our spectral data. If you select this other template, it will also apply SNV scaling to our spectra. This can be useful if you have scatter effects in your images. There are also additional template options to, for example, replace missing values with the median of neighboring values, or to have it automatically generate a PCA or PLS model as it's being imported into the software. Now I will do this manually, so I will have this box unchecked. Okay, we're now done with our import. We have our data set here, and we have a pseudo RGB image generated based on three spectral bands in our spectral profile. And we also have a spectral plot that's visualizing the spectral profile for each pixel we are selecting.